This week I completed 44 problems in section 9. I almost started reading section 10, but I didn't do it. I'm gonna continue trying to finish all the problems. There's 72 of them, and so there were 18 proofs. 35.6% of all the problems in Gallian I've attempted, up to 607 problems. And this video was filmed August 21st. I just came back from a vacation, so I finished almost everything before, but I didn't have a chance to make the video because I was getting ready for, I don't know if I want to call it vacation, more like a family visit. All right, so then on to section 9. Unlike section 8, which went by pretty easily and fast, the external direct product section, this section is a little bit of a mishmash because it starts with normal subgroups where you can have the cosets AH equal to the cosets HA for all A and G, but there's a little bit of a twist, and it's explained by Gallian that as long as you're within G, AH doesn't have to be equal. I mean, the actual elements A and H don't have to be equal. You can have an H prime A, or you can have something like HA is equal to AH double H, double prime. So you're within the group itself, and there's a good example in here, in example 3, where the elements, when you try to equal them, they don't. So 1, 2, 1, 2, 3 does not equal 1, 2, 3, 1, 2, but 1, 2, 1, 2, 3 does equal 1, 3, 2, 1, 2, and 1, 3, 2 is in the smaller group A sub n. So yeah, I think I said that okay. Now in the case of the testing whether it's a normal subgroup or not, I found myself using theorem 9.1 a lot. It's a lot. I felt it was more straightforward. Yeah, it was more straightforward. And then Gallian jumps to factor groups, which of course are built up from normal subgroups, because in the definition you have the H in the G divided by H has to be a normal subgroup of G. There's all kinds of calculations with cosets in this section. Of course, Gallian also uses an example from D4 of creating a factor group, another factor group from integers, then another factor group using the U groups as examples, then some applications, then a couple of theorems that I haven't hit into problems yet, G factor group GZ, and the factor group GZ is an isomorphic to the inner isomorphism of G. And then Cauchy's theorem, dealing with primes. Then the internal direct products, which are isomorphic to the external direct products. Yeah, and I think I may have shown this last time as well. Yeah, I think I did. So anyways, I attempted all these problems here up to problem 44. Got the first problem right. The third problem, I also got it right. These were pretty straightforward calculation problems. The proof of 5, I also got right. The whole business of the H's intersecting into the identity. Then the general linear group as an example. Yeah, problem 7, I got that correct as well. The answer book gave a better answer, a more elegant answer. That is usually the case for the problems that I attempt. Yeah, I didn't give myself credit for number 9. Yeah, my proof was not like the answer, and I don't think I got it correct. A factor group of a cyclic group is also cyclic. I felt like I did it correctly after I looked at the answer. 13, yep, I got it correct as well. 15, not quite. I got confused with some of the terminology, even though I did a bunch of calculations. 17 I was close, but I messed up one term, so I gave myself half credit. Then 19 was very straightforward, just a bunch of calculations. Yeah, I got that correct. I think I waved my hands in 21, gave myself half credit looking at the answer. And then this one I got wrong. I mean, I tried, but yeah. I thought it was the LCM, but it really was just straight up the factors themselves, the orders themselves. Yeah, 24. Yeah, 24 was solved by Bill Kinney after I had attempted it, so I did get it correct. I watched the Bill Kinney video. And I made a note about his playlist of from Gallian. 25 was very interesting because here is where I really learned something that I wish was in Gallian, which is all this this coset manipulation to get the orders correct. And I believe that Bill Kinney is correct. He actually solves it. And in the case of Gallian, I believe the answer in the back of the book and also in the answer book is incorrect. After I did these problems, I found out that there is an errata page for Gallian. I did not go look at it. I did not have time to look at it. But I believe that Bill Kinney is correct in that it is isomorphic to Z8. And so at some point, I just said, you know what? I'm going to just go and actually work out the orders of all the cosets. And sure enough, yeah, there are cosets of order 8, 4 of them. Then more even problems for which I do not have the answers. 27, I also got correct. I went ahead and used Excel. I just kept the table for reference. 28, I think I should have gotten it correctly. I worked it all out in detail, even though I don't have the answer. I also got 29 correct. More calculations with D4. Very straightforward, it seemed to me. Also, I believe 31 from looking at the answer after I worked on it, that I think I got it correct. Yeah, this one I got wrong. I looked at it, just, no, that's not what I said. 35, I also got correct. This reminded me a lot from number theory, things that I used to do in number theory. 37, I looked at the answer and I was like, I was close, but not quite. The correct answer looks a little different. The same for 39. I could have said more. Likewise for 41, even though I waved my hands a lot, the answer was more straightforward. And then for 43, I believe I got it correct. That is, for 43, you're supposed to say, find an example where AH equals BH, but the order of A and B are different. And I do find an example from the rotation subgroup for DN, the dihedral group. I use D4, and sure enough, you take some of the elements from D4, and you get that R0H, R90H, R180H, and R270H are all H, but their orders are different. I think that's correct. The example they give in the book is also correct. I calculated it out. Yeah. All right, that was it for this week.